On July 1st, 2025, a telescope in Chile caught a tiny point of light moving across the sky. It was moving fast. Too fast. And the moment astronomers ran the numbers on its orbit, they knew this thing had not come from anywhere in our solar system. It had come from somewhere else entirely. What followed was one of the most intense, productive, and controversial scientific episodes in years. Every major space telescope on Earth and in orbit turned to look at it. SETI researchers pointed radio dishes at it. Harvard's most famous astronomer publicly asked whether it was an alien probe. And by the time it left our solar system, it had revealed that the universe makes worlds in ways our own solar system never prepared us to understand. If you have never heard the full story of 3I Atlas, you're about to. Subscribe if you want more like this, and let's go from the beginning. The telescope that found it is called ATLAS. It stands for Asteroid Terrestrial Impact Last Alert System. It is a network of telescopes funded by NASA and designed to find rocks in space that might be heading toward Earth. One of the ATLAS telescopes is located in the Rio Hurtado region of Chile. On July 1st, 2025, that telescope flagged a moving object. It was flagged automatically, the way the system flags thousands of potential asteroids. But when astronomers looked at the data and calculated the object's orbit, it was immediately clear this was something different. The orbit was hyperbolic. That single word means everything. Almost every object in our solar system moves in an ellipse, a stretched circle around the sun. Some are nearly circular, like Earth's orbit. Some are stretched to enormous elongation, like long-period comets that spend most of their time far from the sun. But all of those orbits are closed paths. The objects follow them over and over. A hyperbolic orbit is different. It is an open curve. An object on a hyperbolic orbit is moving too fast for the sun's gravity to hold it. It came in from somewhere else. It will swing around the sun, and it will leave forever. It will never come back. And the eccentricity of 3I Atlas's orbit was not barely hyperbolic. It was strikingly so. The eccentricity was 6. For comparison, a perfectly circular orbit has an eccentricity of 0. An eccentricity of 1 is the minimum required to escape the sun's gravity. An eccentricity of 6 means this object was moving with such excess velocity that the sun's gravity barely deflected its path. It had come from interstellar space, the space between stars, and it was passing through on a trajectory that no force in our solar system could alter significantly. When it was first detected, 3I Atlas was about 410 million miles from the sun, already inside the orbit of Jupiter. It was already well into our solar system before anyone spotted it, and it was traveling at about 137,000 miles per hour. That translates to roughly 221,000 kilometers per hour, or about 61 kilometers per second. For context, Earth orbits the sun at about 30 kilometers per second. This object was moving twice as fast as our own planet while already deep inside our solar system. It was the fastest object ever observed passing through the solar system. The previous record holder was also an interstellar visitor, but 3I Atlas came in faster than anything that had come before. It became the third confirmed interstellar object ever detected. The first was Oumuamua, discovered in October 2017, which passed through our solar system and left before scientists could study it as thoroughly as they wanted. Oumuamua was strange. It was elongated, possibly cigar-shaped or flat like a pancake, depending on how the data was interpreted. It showed unexpected acceleration that could not be fully explained by gravity or normal cometary outgassing. It became deeply controversial. The second interstellar object was 2I Borisov, discovered in August 2019. Borisov was more conventional, behaving much like a normal comet, but moving on a hyperbolic trajectory that proved it came from outside our solar system. Scientists got a good look at Borisov and found it resembled comets from our own solar system fairly closely. And now came 3I Atlas, the third. And from the first moments of observation, it was clearly different from anything seen before. The most immediate response from the astronomical community was to point every available instrument at it as fast as possible. Interstellar visitors do not announce themselves in advance. They arrive without warning. They are gone before you can plan a mission to intercept them. The time window to observe them is fixed, finite, and once it closes forever. So, within days of the discovery, observatories around the world began collecting data. Space telescopes, including Hubble, JWST, SphereX, and Europa Clipper, were all directed toward it. Hubble photographed 3I Atlas on July 21, 2025, when the comet was about 365 million kilometers from Earth. From those images, astronomers estimated the size of the nucleus, the solid core at the center of the comet. Based on Hubble's observations from August 20, 2025, the nucleus was estimated to be between 400 feet and 3.5 miles across, between about 440 meters and 5.6 kilometers in diameter. That is a substantial size. The uncertainty is large because The object was surrounded by a cloud of gas and dust called the coma, which made it difficult to see the nucleus directly. But even at the low end of that estimate, 3I's Atlas was a significant object, not something small or faint. The coma itself was immediately notable. Oumuamua had no detectable coma. Borisov had one. 3I Atlas had a large active coma almost immediately after discovery. This told astronomers it was an icy body, something frozen that was heating up as it got closer to the sun and releasing gases. This is exactly what a comet does. But the composition of what it was releasing turned out to be unlike anything scientists had encountered before. NASA's Sphere-X space telescope observed 3I Atlas twice. First in August 2025, before perihelion, and then again in December 2025, after it had swung around the sun. The two sets of observations showed a dramatic transformation. Before perihelion, the spectral signature of water ice was prominent in the data. After perihelion, that ice signature had disappeared and was replaced by something else entirely. Water vapor production had skyrocketed, increasing by a factor of roughly 20 compared to pre-perihelion levels. And in the post-perihelion data, Sphere-X detected organic molecules that had not been visible before. Specifically, it found signatures consistent with methanol, formaldehyde, methane, and ethane, carbon-based organic compounds. The building blocks of chemistry that underlies life as we know it were now being released from the comet as the interior material exposed by the sun's heat vaporized into space. The interpretation scientists offered was that these organic molecules had been buried deep inside the comet, under at least 10 meters of material, protected from the cosmic ray bombardment they would otherwise encounter during their billions of years of travel through interstellar space. When the sun heated the outer layers and burned them off, the interior material was exposed for the first time since the comet formed. What came out was a glimpse of the original chemistry of another planetary system, frozen in place for billions of years and then released into our solar system as 3I Atlas swung around our star. NASA's Europa Clipper spacecraft, which was en route to Jupiter, used its ultraviolet spectrograph instrument to observe 3I Atlas on November 6, 2025, from a distance of 164 million kilometers. This was a rare opportunity because, at that time, Earth-based telescopes were blinded by the fact that 3I Atlas was close to the sun in the sky. Europa Clipper was at a different position in the solar system and had a clear line of sight. The UV observations added another set of chemical data to the growing picture of what 3I Atlas was made of. Then came the discovery that may be the most scientifically significant finding of the entire episode. Astronomers, using the Atacama Large Millimeter Submillimeter Array in Chile, known as ALMA, one of the world's most powerful radio telescope arrays, measured something in 3I Atlas that had never been measured in an interstellar object before. They measured the ratio of heavy water to ordinary water. Water is H2O, 2 hydrogen atoms and 1 oxygen atom. But not all hydrogen is identical. There is a form of hydrogen called deuterium, which has 1 proton and 1 neutron in its nucleus, while ordinary hydrogen has only a proton. Water containing deuterium instead of regular hydrogen is called heavy water or deuterated water. It is heavier than ordinary water because of that extra neutron. In Earth's oceans, heavy water exists but is rare. In comets, from our own solar system, the ratio of heavy water to ordinary water has been measured many times, and is consistently at a certain level, roughly 1 molecule of heavy water for every 10,000 molecules of ordinary water. In 3I Atlas, the researchers led by Luis Salazar Manzano from the University of Michigan found that ratio was dramatically higher. The deuterium content of 3I Atlas was at least 30 times higher than the level seen in comets from our solar system, and it was more than 40 times higher than in Earth's oceans. This is not a small difference. This is an enormous difference that carries a specific physical meaning. The reason deuterium enrichment matters is that the process that creates heavy water in space is extremely sensitive to temperature. The chemical reactions that concentrate deuterium into water molecules require environments colder than about 30 Kelvin, which is minus 406 degrees Fahrenheit. Our own solar system formed in conditions that were cold in the outer reaches where comets formed, but not this cold. The extreme deuterium level in 3I Atlas tells scientists that the star system where this comet formed had conditions far colder and darker than the environment that created our own solar system. The cloud of gas and dust that gave birth to 3I Atlas's home star was at temperatures that have never been seen in the birthplace of material in our own system. Salazar Manzano said clearly, "The amount of deuterium with respect to ordinary hydrogen and water is higher than anything we have seen before in other planetary systems and planetary comets." The study was published in Nature Astronomy on April 23, 2026. James Webb Space Telescope data published in June 2026 added another layer. JWST's near-infrared spectrograph detected not just the high deuterium level, but also found unusually low amounts of carbon-13 relative to carbon-12. The ratio of these two carbon isotopes also carries a timestamp. Carbon-13 accumulates over time as successive generations of stars fuse carbon and release it back into space. Low carbon-13 relative to carbon-12 points to an ancient origin, before many generations of stars had lived and died and enriched the interstellar medium with carbon-13. The researchers estimated that 3I Atlas may have formed as long as 10 to 12 billion years ago, during the era when the universe's star formation was at its peak. Our solar system is about 4.6 billion years old. This comet may be twice as old as our entire solar system, a frozen remnant from an era of the universe we cannot directly observe. These findings together tell a coherent story. 3I Atlas formed in the deep, cold outer reaches of a protoplanetary disk around an ancient star, possibly more than 10 billion years ago. That star likely died long ago. After being ejected from its home system, possibly by gravitational interactions with other bodies, this comet drifted through interstellar space for billions of years, protected inside by layers of material, chemically intact, a frozen fossil from conditions that no longer exist anywhere near our solar system. And on July 1st, 2025, by chance, a telescope in Chile caught it crossing through our neighborhood. But not everyone was content with that story. Almost immediately after the discovery, Harvard astrophysicist Avi Loeb raised questions. Loeb is the head of Harvard's Galileo project, which focuses on the scientific search for evidence of extraterrestrial technology. He had previously suggested that Oumuamua might have been an alien artifact, a proposal that drew enormous controversy and disagreement from most of the scientific community. Now, with 3I Atlas exhibiting unusual properties, Loeb argued that scientists should not rule out a technological origin. He compiled a list of anomalies he found puzzling: the object's high speed relative to the local standard of rest, the unusual trajectory, the retrograde orbit, the collimated jet-like structure in Hubble images before perihelion, the behavior of the coma, the fact that organic molecules survived what would have been billions of years of cosmic ray bombardment in space. Over time, he cataloged 22 anomalies he found unusual for a natural comet. He asked publicly whether 3I Atlas could be an artifact of an alien civilization, possibly traveling between star systems. The SETI Institute and associated researchers responded by doing exactly what scientists are supposed to do when someone makes a claim that requires evidence. They pointed radio telescopes at 3I Atlas and listened. They searched specifically for narrowband radio signals, the kind that would most clearly indicate a technological transmitter, something no natural object produces. The search was conducted carefully, covering the relevant frequency ranges, and the results, published in June 2026, were clear. No alien radio signals were detected from 3I Atlas. The researchers noted that the search did pick up some radio frequency interference, which is human-made radio pollution that can contaminate observations, but no signals that could be attributed to a technological source on 3I Atlas itself. The scientific community's mainstream position was always clearly stated by figures like physicist Brian Cox, who pointed out directly after perihelion that 3I Atlas is a comet made of carbon dioxide and water ices and other materials of natural origin. Cox said its orbit is as expected, and it will swing around the sun and then disappear into the galaxy. He described it as a visitor from another star, a pristine remnant of a long-dead world just passing through. And he asked simply, is that not wonderful enough? The JWST dust analysis, published in mid-2026, confirmed a natural origin by finding that the composition of silicate dust in 3I Atlas's coma is consistent with materials formed in the cooler outer regions of a protoplanetary disk around a distant star. When scientists combined the dust findings with the isotope data on carbon and hydrogen, the picture that emerged was of a comet that formed naturally, under extreme cold, in the outer part of another star's planetary formation disk, billions of years ago. It is not an alien probe. It is something arguably stranger and more beautiful, a direct sample from conditions in the universe that our solar system never experienced, delivered to us by nothing more than the motions of bodies under gravity across cosmological time. The scientific value of 3I Atlas is difficult to overstate. Before 2017, we had never confirmed the existence of interstellar objects passing through our solar system, even though their existence had been theorized for decades. Oumuamua showed they exist. Borisov showed they can be cometary and observable. And 3I Atlas showed that they can carry chemical information from environments radically different from our own, that our solar system is not the universal template for how planetary systems form, and that the universe makes worlds under conditions that would be completely alien to the cloud of gas and dust that created our sun, our Earth, and everything we know. Salazar Manzano said it directly in the paper, describing the heavy water discovery. Our new observations show that the conditions that led to the formation of our solar system are much different from how planetary systems evolved in different parts of our galaxy. That sentence, published in Nature Astronomy in April 2026, is one of the most significant statements in planetary science in years. It was proven by a comet that drifted for billions of years between the stars before a telescope in Chile noticed it crossing our sky. And here's one more thing worth sitting with. 3I's Atlas is now gone. It passed Jupiter in March 2026 and has been heading out of the solar system ever since, decelerating slightly as the sun's gravity pulls on it from behind, but moving fast enough that it will escape entirely. It will not come back in our lifetimes. It will not come back in the lifetime of our civilization. It will drift back into the interstellar void, carrying the same frozen chemistry it carried in, minus whatever the sun and our instruments managed to read from its surface. In tens of millions of years, it may pass through another stellar neighborhood. Some other world, if one exists, might have instruments that catch it and study what it is made of. And if they measure the deuterium, they might figure out the same thing we figured out, that this object came from somewhere very cold, very old, and very far away, in a universe far larger and stranger than any single solar system can contain. Subscribe, share this with someone who thinks the solar system is the whole story, and drop a comment with what question you most want answered about 3I Atlas. I want to see what you're thinking. See you next time.